Principles of Programming, Lesson 7, ASCII Code and Binary. Today's lesson, we are going to better understand what really an ASCII code is and also its binary representation. Having said that, when you talk about ASCII code simply means American Standard Code for Information Interchange. This is a 7-bit code. That is, it represents character using a 7 bits. Now remember, in our data representation in semiconductor memory, I then talk about, when you talk about a bit is a character, a symbol, space, okay, numbers. These are all what characters. And where we better study to understand that a word is a collection of bits, a group of bits forms a word. Where I give example by saying, when we have the, for instance, the, okay, the, for instance, there is a word, okay, and it is made up of what? Bits. So this word is a collection of bits where we have THE. So a bit is a collection of what? Characters. So a bit indicates characters. Having said that, so an ASCII code is a 7-bit code that it is used to represent character using 7 bits. It is capable of representing up to 128 characters in alphabet, digits, and even special cases. Come think of it, American Standard Code for Information Interchange, it is used to organize, I would say, digital or data communication, and also it is meant for printing purpose. This simply means that when we type a sentence like the boy is going to school, the computer does not see the boy is going to school as the boy is going to school, but it uses an ASCII code to represent each character in the sentence and also convert it into what? Into a binary system. So therefore, it uses a binary digit to represent each character in a sentence. Don't worry, we'll be covering that section when we come to for you guys to better understand it, to understand which will be today. We'll be looking at it. Having said that, now we understand what an ASCII code is. For us to better understand that it is a 7-bit code, let's look at something. We are going to learn how to use command prompt to display an ASCII code key. Okay, simply put, the alphabet in which what ASCII code used to or the computer used an ASCII code to represent an alphabet. Now when you watch here, what we have, so the code is up to what 32 to 126. okay, so you can use loop in command prompt to what? To show character for an ASCII code in what? In your computer, for you to know the ASCII code in which the computer used to represent a key on your what? On your keyboard, and as well as what? When you are even using your phone to type, the binary code representative. So now when you are using something we call looping in command prompt, you must use this code, okay? But come think of it, this code will not display the alphabet for you, but it's going to then display all the ASCII code without not showing the alphabet. Let me show you a typical example. So a typical example, as you can see here, this is it here. So I'll highlight on this, I'll copy from to the end here, and I'll hold on to Ctrl+C to copy. Then after that, I'll launch my command prompt, press the start button on your keyboard, which is the window key on the keyboard, and type CMD. Go ahead and press enter. Now after you press enter, as you can see on your screen, this is what my command prompt. Let me zoom it. I'll go ahead and clear the screen by typing CLS. Press enter. Then after that, just go ahead and paste your what? Your command prompt code that we copy, which is going to be available on your course portal. So far, the slide that will be attached in the course portal for you to download is concerned. So I'll paste that, and then you can see it will display all the code for me. But come think of it, it's only displaying only the ASCII code. Now, as I just said, 32 here indicates space. So when you are typing there and then you press the space bar, the computer uses an ASCII code of 32 to indicate what? The space. But in case you want to know the alphabet and their ASCII code, as I just said, in case you want to know the alphabet and their ASCII code, so as you can see on your screen, now you must use this command. And when you use this command in command prompts, okay, it will display the ASCII code and the character that represents, okay, any ASCII code that you see on your keyboard. So how do we do this? So for you to do this, as you can see, I'll copy the code here, which is the command prompt code. Now this command, as I just said, will be available in your course portal with a PowerPoint slide. You can go ahead and download it. So I'll go ahead and copy that and then open my command prompt. As you can see, now you see this does not display the characters, but it displays only the ASCII code. So I'll go ahead and clear the screen, CLS, and press enter. So I've cleared the screen. So go ahead and paste your second command, which it will display the characters with their ASCII code. So hold on to Control and press V, and then you go ahead and wait for it and to start to display. You can see it's displaying all. So on your keyboard, every character or text or alphabet you press, okay, have its own ASCII code, as you can see on your screen. So we have 32 is space, okay, there's nothing there. 33 is the exclamation mark, and then when it comes to capital A indicates which is 65. So let me scroll down and show you. For example, you see here capital A is 65 here. Are you getting the one I just highlighted? And then in addition to it, also when you go to small a is going to be 90. Since it's 90, small a will give us 97. Okay, small a is 97. So as a programmer, you must know that every alphabet or anything that you type on the keyboard, whether it's an alphabet, it's a movie, or whatever, the computer uses a binary code, more or less an ASCII code, to represent that. And this ASCII code, these are all in base 10. So and then using the binary coded to indicate it to each alphabet. Don't worry, in our next lesson we are going to break it down for us to better understand the way you manage the computer, then convert the ASCII code into a binary system for you to better understand it. Now, having said that, let's look at a typical example for us to better understand the way you manage the computer, then convert the ASCII code into a binary system. So for instance, let's assume that we have the alphabet known as T. Only T. Okay, now let me share something. Now the alphabet T, okay, you can see this is its binary code, which is 1010100. Then we also have an alphabet A, and this capital A being an alphabet, this is its ASCII code, which is 65, and then the binary code is 10000001. Say, I don't understand. How does the computer does that? Now let's look at it, and as I told you, our next lesson I'm going to throw more light on ASCII code and binary coded convention for you to better understand the way you manage the computer represents each alphabet with so far as the ASCII code and the binary is concerned. Now I just said that let's assume we have letter T, okay, or probably let's say letter A, okay, letter A for instance. Now this is letter A in caps, of course. So now letter A, we realize that its ASCII code is 65. Okay, the ASCII code for letter A is 65. So how does the computer convert that into a binary system of getting 10000010? Okay, how? In which way does the computer does that? Now let's look at that. So because the ASCII code you can see here is already in base ASCII code is always in base 7, but so far as in 64, just assume that it's in base 10 already. So just go directly and then just draw your line as we always do, okay, and then I'm going to have my 65 here. okay, and then I have my remainder here, and then I have my base 2, okay. So 2 going to what? 2 going to 60 what? 65 32 times, okay, 32 times. So remainder what? Remainder 1. Then 2 going to what? Goes into 32 what? 16 times, 16 times. Remainder what? Remainder 0. Then 2 again goes into what? Into 16 8 times. Now this simply means that 2 times 8 will give us 16. So that is remainder what? Remainder 0. In addition again, 2 goes to what? Goes into 8 how many times? 4 times. And this gives us what? Remainder what? 0 again. Now 2 goes into what? Into 4 how many times? 2 times. And this gives us what? Remainder what? 0. And now 2 goes into what? Into 2 how many times? 1 time. And remainder what? Remainder 0. Now 2 goes into 1, it's not possible, so it's 0. And in case they want to, then it's going to be left with what? 1. So therefore the ASCII code for capital A, for instance, okay, being the ASCII code of what? 65, the computer then uses a binary code known as what? 1 0 0. You pick it from the down. 0 0 0 1. So it's 5 here. 1 base 2 to represent what? Capital A. So this is what you must understand as a programmer, that anything you write, or so far as what? Anything that one type, the computer uses a binary code to represent what? To represent that alphabet with the help of the what? For the of the ASCII code. Now you've understand that. Don't worry, in our next lesson I'm going to throw more light on ASCII code for us to better understand what an ASCII code conversion is. Thank you so much for watching, and remember, that is just that.
Armstrong computers were leading the way, bringing ICT to your doorstep every day. Where vision meets excellence, we stand strong, transforming students where they belong. In the halls of knowledge, we light the spot.